Today we're going to talk about the formation of the universe. Our learning targets are: I will describe Big Bang as a theory of how the universe began. I will cite evidence used to develop that theory. These are photos. Some are artists' interpretations, but of outer space, such as nebulas. I'm going to talk about those things. Starry night sky, all the things in our universe, galaxies. This is the surface of Jupiter. Some say we are made of stardust. What does that mean to you? Think about that as we go through our topic today. And just know that increasing our knowledge of the universe will increase our knowledge about ourselves, and we'll talk about that. So first things first, what is the universe? Well, the universe is everything: planets, stars, galaxies, space, and even time. No one knows how big the universe is, and it's estimated to be 12 to 15 billion years old. Astronomer Edwin Hubble observed through a telescope that galaxies are moving away from each other, and he called it redshift. Okay, so if you're thinking Edwin Hubble, think about the Hubble telescope. Well, what is redshift? Redshift is when the wavelength of light is stretched so that it is shifted towards the red part of the spectrum. And when it shifts towards the red part of the spectrum, the wavelength is becoming longer. It's stretching. Okay, so here's an interpretation. We have 3 galaxies, and they're all moving towards the red. That wavelength is stretching, so it's redshift. If it were moving closer to Earth, what do you think we would call that? Right, blue shift. So let's get into it. The Big Bang. We think of it as an explosion, but it's not an explosion. It's actually a sudden expansion outward, and that's where we have nebulas. So this picture right here is a nebula. It's a lot of gas and dust. The Big Bang marks the beginning of space and time as we know it. So there is evidence that supports the Big Bang theory. Notice that it's a theory and not a law. Redshift. Stars and galaxies are expanding as indicated by wavelengths in space. So that's evidence that supports the Big Bang theory. Another piece of evidence that supports the Big Bang theory is cosmic radiation, and that is radiation from the sun and beyond the solar system. And that cosmic radiation is made up of microwaves, like the waves that cook our food, and radio waves, the waves that carry sound to us when we're in our cars. So how did the universe go from one speck to all that there is now? What happens is, after the Big Bang, after that sudden expansion, the universe started expanding. We had protons and neutrons and electrons, the building blocks of atoms. They appeared and they got together and they eventually formed the first star, which we call Sol. And those stars then created galaxies. Okay, so massive stars called supernovas, they exploded. They reached the end of their lifetime. They explode and they produce even more different types of matter, which form other things in our solar system, such as all of the elements on the periodic table of elements, all the way to us, even humans. Okay, so think about that quote that I showed you earlier. Some say we're made of stardust. If stars exploding produced all of this matter, eventually it would lead to us. We're made up of matter. We need to answer our essential questions. What is the Big Bang Theory? What evidence is used to support the Big Bang Theory? We want to use our notes to answer these questions. And when we answer these questions, we want to keep in mind our learning targets so that we know that we are learning what is expected of us after this topic.